And then we have, let's talk about, for example, fluorine. Which is 1:2, 2:2, 2p6, 2p5, is it? 2p5, yeah. Yes. So what is the core electron for fluorine? 2. 2 again, core. How about valence?
7.
7. You have to be careful with this, and you have to know it very well. All right. Okay. Now, what is the effective? Is the effect of the nucleus on the outer electron. All right. Why does it effective for fluorine is more than for lithium? Why? Because in fluorine we have 9 protons, and here we have only 3 protons. So here, one of them is 9, one of them is 3. They have the same core electrons, which is 2, but the valence electrons are, which one will be attracted more to the nucleus in the case of fluorine or lithium?
Fluorine.
Fluorine will be much more attracted. As I told you last time, I don't want you to memorize these numbers, but what do you notice as you go across the periodic table?
It increases.
Is that effective? Increase. Is this clear? This is very important. We are going to have many subjects related to this thing. As I said, I don't want you to memorize the numbers, but you can see you start from 1.28 to 1.191 to 2.24 until you go to 5.10. This means it's increasing as you go across the periodic table like this. Very good. Now, we'll go to another subject, which is the atomic radius. What is the atomic radius? If you have atoms like this together, what's the radius of this atom? If we assume that the distance is the nucleus to the nucleus, if we assume this distance is a, then what's the radius of the atoms?
A divided by 2.
Yes, A divided by 2.
A divided by 2, as simple as that. Because we want, why did we do it for 2 atoms? Because we can see the nucleus, and the nucleus, the electrons are like light, we cannot see them. And that's why we measure the distance from the nucleus to the nucleus, and then take half of that distance, and this half distance is the radius of the atom. Good? If we have 2 atoms only, same thing. We have the nucleus, like, for example, this is oxygen, this is the nucleus, and this is the nucleus. And we can measure distance from here to here, and let's assume it is A. Then what is the radius of this atom, or maybe it's oxygen?
A
divided by
2.
2, same thing exactly. Now, what will happen if you, because of Z effective, how does it increase in the periodic table? How does it increase? From this side to this side, right?
Yes.
Okay, now the nucleus will attract the valence electron stronger in here or in here, in 1 or in 2?
In 2.
And what will be the result? What will be the radius of 2 compared to 1?
Bigger.
Smaller.
Smaller. Radius smaller. Why? Because more attraction. Clear? The following. This is the radius of lithium, going from lithium to Be to B to C to NOF and Ne. What do you notice as you go across from lithium to neon?
The radius.
The size of the size decrease. The radius also what?
Decreasing.
Decrease. Give me a reason.
Because it attracts more electrons.
Of what? Because of the effect of what?
Z effect.
Exactly. Because it is the effect. As I told you, this is the nucleus. And the core electrons for all this whole group, the core electron is only 2, 1 and 2. And then the rest are on the valence electrons. And as you increase the number of valence electrons, the attraction to the nucleus become more. Why? Because the number of protons become more and more and more. Look at the number of, how many protons do you have in lithium? 3, and then 4, 5, 6, 7, 8, 9, and 10. Fluorine will attract the valence electrons much more than lithium. Why?
Because of the number of protons.
Yeah,
Because
it has
you have
more.
9 protons in fluorine, while for lithium is only 3. And because the core electron is the same, but the valence electrons are different, but they will attract it more and will have the size. Now, tell me why the size increases as you go down.
Less attraction to the electron.
Not only that, but you are what?
The
More
electron is further.
Building more
That's-
shells. Can you see? You are putting more and more and more shells.
More shields.
More shells. Shell,
Oh, okay.
not shell. كرة يعني. And this meaning more shell, I mean more balls, if you want. It's not never used, but it's more balls. يعني انت تحط كور على ال, because you are putting more and more and more and more electrons, and so the size increase this way. So generally size decrease this way, decrease, and increase this way. Clear? Any question? Good. Now, we will talk now about mainly, let's go back to this one. If you notice here, look, do you have your periodic table? I want you always to bring your periodic table. Do you know which elements that we're talking about here?
Arca.
These are what? The S and the P elements. You remember?
Yes.
Oh, yes.
Yes,
Yes.
yes.
These are called what now? They're
Main
called
group.
the
Main group.
main group element, which is S and P elements. I want you to know this. All this chapter is talking about main group. We're not going to talk about transition metal in this chapter. Clear? Any question? Now,
Doctor,
yes.
if we want to compare between, if we compare in the size between premium and lithium.
Okay, let's do this problem, and I'll answer you through this problem. We have 3 elements. Go to your periodic table: phosphorus, sulfur, and oxygen. If you look at your periodic table, this is how they are arranged. Go to your periodic table. Now, from the size point of view, which is bigger, phosphorus or sulfur?
Phosphorus.
Phosphorus.
Why? Phosphorus is bigger?
Yes.
Yeah.
Yes, fine.
Because it has more shells.
What?
Because it's on the left.
Because we are moving this way.
Less
right?
attraction.
Which is bigger, sulfur or oxygen?
Sulfur.
What?
Sulfur.
Sulfur is bigger, so the size decreases this way. So which one is the biggest among these 3?
Phosphorus.
And then,
Phosphorus.
and then,
Then sulfur.
Sulfur.
Sulfur oxide.
No.
okay, clear? I hope this is clear. Does this answer your question?
Yes.
Now, let's talk about another subject. Look at this reaction. What's this?
Sodium.
Sodium what?
Sodium.
Gas.
Gas. And this gives us
Sodium ion.
Sodium.
Sodium ion, yes.
sodium ion what?
Gas.
Gas
Gas.
plus electron. This is a chemical reaction. It has heat. This heat delta H. This heat is called ionization energy. Ionization energy. So we're going to call this delta H ionization energy. I want you now to define what's ionization energy. Define it.
Energy needed
Yes.
to remove an electron
From
from an element, neutral atom.
Gas.
what any element? What type of element? What physical
Gas.
state?
Gas.
Gaseous element. Not solid, but gaseous element. Is this clear? So ionization energy is the minimum energy required to remove an electron atom in the
Gas phase.
gas phase. So if I want you to write ionization energy, you should have everything in gas phase and then write equation like this one. So this equation represents ionization energy. Is this clear? Clear?
Yes.
Very good. I hope so. Now, ionization energy, what are this group again? What's this group of elements?
Main
Main
group.
group.
Main group.
Yes.
What's the other name that we use for it?
S&P.
S&P elements. Keep this in mind. Okay, good. Look at the first group, which is from lithium all the way to neon. Okay, and lithium, Be, B, carbon, nitrogen, oxygen, fluorine, and then neon. And look at the numbers. What's this? 520, 899, 800, 1086, 1402, 131214, 1681, and then 2280. These 8 numbers that you're looking at 8 numbers. What do you notice about these 8 numbers?
Increasing from the left to right.
First observation, very good, that actually it increased from this one, this side to this side. By the way, this is the ionization energy for the elements, the first ionization energy. First ionization energy to take 1 electron. This means we have X gas goes to X plus gas plus electron. That's the equation that we're talking about. This is the energy delta H for this reaction. Clear? And what's the first thing you notice?
It's increased from left.
Increase from left to right. Right? From this side to this side. Increase. What do you think the reason? Yes.
The nitrogen is greater than oxygen. Why?
Just a second. Why do you think the reason it increased from left to right?
Because the attraction between the nucleus and neutrons are stronger.
Very good. What attraction? What do you mean by attraction?
The size of
Huh?
the size of the
Nucleus.
Attraction of the nucleus. Why the attraction in the nucleus is more effective?
Because of fluorine
Number
and
of
oxygen has bending.
Stability.
Because generally, what is the Z effective?
It's higher.
The Z effective increase from this side, and Z effective attract the outer electron. Clear? And when you want to take it, you need to put more energy. Is this clear? Hello?
Yes, it's clear.
I hope so. So the generally the the ionization energy increase from left to right. The reason is because of Z effective. Z effective increase from this side to this side, and as Z effective increase, taking electron is more difficult and you need more energy. Do you see any exceptions?
Oxygen,
Oxygen and
nitrogen,
nitrogen. Very good. What else?
B, E, and B.
Be and
The group 5A and 6A.
no, just talk. Let's talk about this group only. Just talk about this group only.
Okay.
Okay. So we see two exceptions, right? Very good. Let's explain why the exceptions. First, for nitrogen and oxygen, I will draw the electron structure. 1s with 2 electrons, and then 2s, and then 2p. Okay, for oxygen, it is 1s with 2 electrons, 1s, and then this is 2s, and this is 2p, of course. And then 2s, also with 2 electrons, and then 2p with how many electrons?
4.
1, 2, 3, and 4. Now, I want you to tell me why oxygen did not, the Z effective of oxygen, let's go back to Z effective. What is Z effective oxygen?
4.4.
4.45.
Which one is more?
Oxygen.
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 oxygen,
Which one should attract the valence electron more?
oxygen,
طيب. ليش then we see that in this case oxygen needs to take the electron away is easier in oxygen than in nitrogen? There is another reason. Look at the electronic structure and tell me, what do you think the reason? Because in this room or in this box, what do we have?
Maybe 3 is more stable.
We have 2 electrons. What will happen if we have 2 electrons together in the same room?
Opposite direction.
They will repel each other. Electron, what's the charge on electron, by the way? What's the charge on electron?
-1.6 times 10 to the power -19.
الشارج اللي احنا نعرفها نستخدمها.
Minus
ماينس what?
1.
1. والبروتون كم عليه؟
Positive 1.
Positive 1.
والنيوترون
0.
Yes. Okay, if we have 2 electrons, they have the charge -1 and another electron with -1. What will happen to them? 2 magnets with minus and minus. What will happen?
0.
No, minus and minus.
Oh, okay. -2.
2 electrons. هنا في electron وفي electron ثاني in the same room, and this is -1 and this is -1. What will happen to them?
Okay, or not attract.
Repel.
Positive.
Yes. Repel. Is this clear? Repel. What do you mean by repel?
Opposite of attraction.
تنافر.
wrong.
تنافر نعم تنافر. This helps the electron to go away, and that's why this becomes less than nitrogen. Is this clear? Is this clear?
Yes.
Okay, next one.
Yes.
E and B. Let's draw the BE, which is 4, and B, which is 5. So what's the electron structure of B? BE. Okay. For B, it is okay, this is the electronic structure for BE and B. Now